All right, guys, we are going to take a look at the homework for Thursday, September 6th. And this is solving linear equations and inequalities where you have one solution, no solutions, or infinitely many solutions. And so we are used to solving equations that only have one solution. And that's what we're being asked to do in number one. We're being asked to provide two examples of equations, each having one variable and exactly one solution. So I'll provide two examples. The first one will have a variable on each side, still one variable, and then the second one will be a more traditional. So I have 3x plus 4 equals 2x plus 8. And the reason I know that this is going to have one solution is because I'm going to be left with a variable on one side. I am able to isolate the variable, and I will have a number that it is equal to. So if I subtract 2x from both sides, actually I'll draw my line down here. If I subtract 2x from both sides, I'm left with 3x minus 2x, which is x plus 4 equals 8. And if I subtract 4 from both sides, I'm going to be left with x equals 4. Okay, so that's one variable with one solution. A more traditional problem that we've seen before would be something like 3x plus 9 equals 12. Using my inverse operations and properties of equality, I'll subtract 9 from both sides. I'm going to be left with 3x equals 3. If I divide both sides by 3, I'm left with x equals 1. So there are two equations in which I was able to isolate the variable on one side and be left with a single number that would make the equation true. My second question here is, which equation has infinitely many solutions? You will see this sort of infinity symbol like this, and so if you see that with the word solutions after it, that's what that means. So if I'm looking at number one, it says here x plus 7 equals 7. And now if I were to solve this and subtract x from both sides, I would be left with x equals 0. So that's not infinitely many solutions. Here I have 2x plus 7 equals 17. Again, if I were to solve this, I would subtract 7 from both sides. I would be left with 2x equals 10. Divide both sides by 2, and I would be left with x equals 5. So here, for example, x is equal to 0. Here, x is equal to 5. So it's not going to be this one. Now in this problem, I have 3x plus 7 is equal to 3x plus 12, and I'm going to show you here how I would do that. 3x plus 7 equals 3x plus 12. If I were to attempt to isolate the variable, I would subtract 3x from both sides. It would eliminate the 3x altogether. I'd be left with 7 equals 12. That's not true, right? And that's how we say that's not true. So that has no solutions. Over here, I have 3x plus 12 equals 3x plus 12. I have the same coefficient for my variable, and I have the same constant, which means when I subtract 3x from both sides, I'm left with 12 equals 12, which means I have infinitely many solutions here. What does that mean when I say that I have infinitely many solutions? Well, if I were to plug any number into the x, I would end up with a true solution. So if I were to say, let's have x equal 5, and I did 3x plus 12 equals 3x plus 12, I would have 3 times 5 plus 12 equals 3 times 5 plus 12, meaning I would have 15 plus 12 equals 15 plus 12, which means I would have 27 equals 27, right? So that's my infinitely many solutions. I'm going to come down here and solve this equation for number 3. So here I have x plus 25 is equal to 25 plus x, and already in my head I'm thinking, this probably has infinitely many solutions. Let me just work it out. So I'm going to subtract x from both sides. Okay, and I'm left with 25, equals 25. So x could be any number. All right, I'm gonna let you guys do number 4 on your own because we've already kind of talked about that. And then also I want you to remember to do this second page on your own. Today's objective was not as work intensive as yesterday's objective, but we do want to make sure that we understand these definitions because our equations are going to quickly become more complicated, and we're going to have to work them out to figure out whether or not they have 0 solutions, 1 solution, or infinitely many solutions. I also want to let you know that this is an objective that we're paying very careful attention to across all of our 8th grades, across all of Uncommon Schools, because we know that being able to solve equations and know what we're ending up with, what kind of math statement we end up with, is going to be critical as we move through algebra this year. And good luck, gentlemen. I will see you tomorrow.